Good morning, dear students. My name is Radhe Syam, and we are discussing error analysis. We know that measurement is the foundation of modern science and technology. So to find out any physical quantity, or to find out true value of any physical quantity, we need to perform an experiment. And we know that when we perform an experiment, it will include an instrument to take the reading and some experimental procedure that we have designed to take the observation. And then there will be an observer, or you can say an user, that will be taking the reading or will be observing the experiment. And this experiment will be always happening in the background of an environment. So environment will be also an impacting factor that will impact the result of any experiment. So we are saying that to find the true value of any physical quantity, we have to always perform an experiment, and all experiment will constitute these basic steps, or you can say these basic factors. Any experiment need to have an instrument, an experimental procedure or technique, an observer, and the environment. And because of these things, there will be always some uncertainty, or you can say there will be always some error in the measurement. So it is almost impossible, or you can say it is not possible to have any kind of error in the measurement, or to be very certain that whatever we have measured is the true value. It is almost impossible, because there will be always some kind of uncertainty in measurement. It could be because of instrumental factor, experimental procedure, or because of observer, or because some uncertain or unknown cause by environment. So there will be always some uncertainty in the measured quantity. So whatever measured quantity we have obtained by the experiment, we need to know that how accurate is that reading, and what is the precision of the experiment. So these two terms are very important whenever we are performing an experiment to find a true value of any quantity. So we want to know that what is the accuracy of the experiment and what is the precision of experiment. So you can say that, for example, we can say that, let's say that we have measured a length, and the true value of the length is 3.726 centimeter. But after measurement we are finding out, let's say that we find out 3.5 centimeter. We have done an experiment, and we have find by one experimental procedure we have find the value to be 3.5 centimeter, and by another procedure we have found that 3.256. So we will say that this 3.5 centimeter is more accurate, this is more accurate, and this is This is not more accurate, but this is more precise. This is more accurate, and this is more precise. So, or this has higher precision but less accurate. So whenever we are performing an experiment, we need to be very sure that our experiment is accurate, and in accuracy this need to include that precision of the instrument must be also great. So precision also means that what is the limit of measurement, what is the limit of the instrument, or you can say what is the resolution of the experiment, resolution of instrument, how small a reading this instrument can take. So accuracy means how close it is to the true value. So we are saying that to find the true value of any physical quantity, we need to perform an experiment. An experiment always have these components, you can say components or factors affecting an experiment, that is instrument, experimental procedure, observer and environment. And because of these factors, there will be always some uncertainty in the measurement. Uncertainty is also called error in the measurement. So because of these factors, there will be always some error or uncertainty in the measurement. So our measured quantity will always have some uncertainty in its measured value or some error in the measured value. So we want to be very sure that it is accurate, and accuracy means how close our observed value or our measured value to the true value. And precision means what is the limit or the resolution of the instrument. Hopefully you can understand this.